As we've seen in the first part of this tutorial, the best way to graph the secant and cosecant function was to use the reciprocal function sine and cosine, and that is in general my advice for you. When you're graphing secant and cosecant functions, always graph the corresponding sine or cosine function first and then take it from there. So in our first example, we got y is equal to 2 cosecant of x plus pi over 4 plus 1. And cosecant being the reciprocal of the sine, we would first graph the function y is equal to 2 sine of x plus pi over 4 plus 1. And in order to do that, we need to now remember all the characteristics of the sine function: amplitude, period, horizontal, and vertical shift. The amplitude of this function is 2. The period is 2 pi, which makes the quarter period pi over 2. The horizontal shift is c over b. Remember, for the c we need to switch the sign, so it's negative pi over 4 divided by 1, or just simply negative pi over 4. And our vertical shift is the value that's in the place of d, and that is positive 1. So now with horizontal and vertical shift, the best way to graph our sine function is to find that initial point that in our parent function is 0 and take it from there. That point will have the coordinates that are determined by horizontal shift and vertical shift, negative pi over 4 and 1. I'm going to put a rectangle around it, and that's going to be our first point, negative pi over 4 and positive 1. This is our initial point for our sine function. And from there, we now go to the next point, which would be our high point. And since our amplitude is 2, our high point is 2 points up. Then we go back to the same level as our initial point, down to a low point, which is also amplified by our amplitude, and back to 0. And here we have our sine curve over the first period. And this will now allow us to graph our cosecant. First, we're going to put our asymptotes down, as we always do when we have those. And those go through the points where our parent sine function has a 0 and our modified sine function has the vertical shift. So here, here, and here are our asymptotes and our cosecant curves then go like this. Our domain for this cosecant function is x, such that x is not equal to, and where do we see our first positive asymptote? It's at 3 pi over 4, and it will repeat after pi periodically, so plus pi k, and the range goes from negative infinity all the way up to negative 1. And the other part starts at positive 3 and goes all the way to positive infinity. And on we move to our next example. I'm skipping over the next one on your sheet and going to the third one. You can do the other one yourselves. And here we got y is equal to negative 3 cosecant of x minus pi plus 1. Cosecant function again means that our corresponding function, reciprocal function, is y is equal to negative 3 sine of x minus pi plus 1. we have an amplitude of absolute value of -3, which is 3. We have a period, which is like our standard period, 2 pi, and it makes our quarter period, again, pi over 2. Our horizontal shift is pi over 1, or just pi, and our vertical shift is, again, 1. Since our quarter period is pi over 2, we're going to put the horizontal shift on the same denominator. That makes it 2 pi over 2. It's just easier for us to graph. And horizontal shift and vertical shift together will give us the initial point for our sine function, 2 pi over 2 and 1. And 2 pi over 2 is nothing other than pi itself. Up 1, that is going to be our initial point. You have noticed that I have labeled the y-axis slightly differently, and that is just so we have a chance to see both ends of the cosecant function. And now let's remember, sine follows our memory trick oholo, but our a has a negative sign, so that means it's flipped over the horizontal line, which is determined by the vertical shift. So really we have low ho, if you want to think about it this way. So we're going from 0 to the lowest point first, then back to 0 to the highest point, and back to 0. This is the corresponding sine curve. And now we're ready to graph our cosecant. Asymptotes are where the values lie that are on the horizontal line determined by the vertical shift. And our curve starts at the point 1 and goes towards -infinity on the part that is below the x-axis, and to positive infinity where the sine curve lies above the x-axis. Let's determine domain and range real quick. The domain is x such that x is not equal to pi is our first asymptote, and then it repeats every pi, so it's really just pi k. And the range starts at -infinity, goes to -2, and it continues at 4 and goes on to positive infinity. Very good. And now on to our last example. We're skipping another one for you to do by yourselves. Here's our last example. Y is equal to 2 secants of 3x minus pi over 2. The secant function is a reciprocal of the cosine functions. So now we're going to have our corresponding function. Y is equal to 2 cosine of 3x minus pi over 2. This means we have an amplitude of 2. We have a period of 2 pi over 3. That makes our quarter period 2 pi over 12, which is the same as pi over 6. Our horizontal shift is pi over 2 divided by 3. So what does that mean? Dividing it by 3 over 1 would be the same as multiplying it by 1 over 3. And that makes the horizontal shift pi over 6, which is the same as our period. That is quite convenient. Our vertical shift this time is 0. We're going to start our cosine function at the point pi over 6 and 0, putting my rectangular box around it to indicate it, and this is where that point lies. Now let's label our x and y axis first. I haven't done that because I wanted to go through it with you again. Remember, if the period is something with a denominator of 6, we're going to deviate from our normal procedure and we're going to mark pi after 6 boxes and 2 pi then accordingly after 12. And also because of our amplitude, we're going to mark the y-axis a little more closer together. And now we're ready to graph our cosine function. We're starting at the point pi over 6 and 0. This one is right here. But remember, cosine is hollow. So while this is the 0 point, we are starting at the high point, and the high point with an amplitude of 2 is at 2. And now we're going to move 1/4 period, which is just 1 box down to get to 0, another box to get to the low point at -2, another box to get back to 0, and another box to get back to our high point. And here we have our cosine function. That means we can now go ahead and graph our secant. Asymptotes will be where the cosine is at 0. Much closer together this time because our period is much smaller. And our secant curve then goes touching our cosine and going back towards the asymptotes. Here's our cosecant function, and let's just get the domain done here. X such that x is not equal to, where is our first positive asymptote? It's at pi over 3, and then it follows at every pi over 3, so pi over 3 times k, and our range starts as usual at -infinity, goes all the way up to -2, but the other part of it starts at +2 and goes to +infinity. All right. As I said before, the other two examples you can do and try by yourselves. This is it for today. I will see you in class where we'll review those other two examples. See ya.